Good day, students. I'm Mr. Jeffrey N. Isla, a grade 10 science teacher from Tagaytay City National High School. And for today, we're going to discuss the different factors affecting the rate of chemical reaction.
Grade 10 Science Quarter 4, Weeks 7 to 8. The title of our lesson is Factors Affecting Chemical Reactions. Most essential learning competency. Explain how the factors affecting rates of chemical reactions are applied in food preservation, control of fire, pollution, corrosion, and materials production.
Chemical reactions are integral part of technology, of culture, and indeed of life itself. Burning fuels, melting iron, making glass and pottery, brewing beer, and making wine and cheese are among many examples of activities incorporating chemical reactions that have been known and used for thousands of years. Chemical reactions abound in the geology of Earth, in the atmosphere, in the ocean, and in a vast array of complicated processes that occur in all living systems.
Chemical reactions must be distinguished from physical changes. Physical changes include changes of state such as ice melting to water and water evaporating to vapor. If a physical change occurs, the physical properties of a substance will change, but its chemical identity will remain the same.
No matter what its physical state, water is the same compound, with each molecule composed of 2 atoms of hydrogen and 1 atom of oxygen. However, if water as ice, liquid, or vapor encounters sodium metal, the atoms will be redistributed to give the new substances molecular hydrogen and sodium hydroxide. By this, we know that a chemical change or reaction has occurred. Okay, students, so let us do learning task number 1, race to the finish line. So write the answer on your notebook. Guide questions. Number 1. What causes a chemical reaction? Number 2. What must happen for a chemical reaction to take place? Number 3. Describe a fruitful, effective collision resulting to formation of products.
Collision theory. Collision theory explains how collision between reactant molecules may or may not result in successful chemical reaction. So based on this theory, not all collisions between the molecules which result in the formation of products only occur when the following 2 conditions are met.
Letter A. The colliding molecules should possess a minimum kinetic energy known as activation energy to start a chemical reaction. Letter B. The reactant molecules should be in correct orientation when they collide.
Activation energy. Activation energy is needed to break the bond between reactant molecules to form new bonds, leading to formation of products. Okay, students, this time I will show you some experiments about the factors affecting the rate of chemical reaction. So you can also do this experiment in your home and even in your school. Okay, let's begin. So in this experiment, I will show you how temperature affects the rate of chemical reaction. So we need 2 glasses. Then we also need 2 vitamin C tablets. Then we need careful with this experiment, especially with the hot water. First, so let's pour some amount of cold water in a glass. And then, let's pour some hot water in our glass. So again, be careful with this experiment, especially with the hot water. Okay, now we're going to put the 2 vitamin C tablets at the same time. Then observe what will happen. So as you can see, the vitamin C tablet reacts first on hot water compared with the cold one.
Temperature. The higher the temperature, the more particles gain energy and cause them to move faster. The faster the particles move, there is an increasing tendency to collide frequently and produce more energy. Through this, activation energy is more likely to exceed. As a result, there will be a higher rate of successful reaction.
In this experiment, I will show you how concentration affects the rate of chemical reaction. So we need 2 glasses, vinegar, baking soda, then we also have
2 glass bowls and a measuring cup.
we also need basin.
First, we're going to put the same amount of vinegar on each glass. And then we're going to put 1/2 cup of our baking soda on the smaller bowl. And then we will put 1 cup of our baking soda into our big bowl. And then we're going to place our 2 glasses to our basin. And then we will put the 2 amounts of baking soda at the same time. Then observe what will happen. As you can see in our slow-mo video, the big amount of baking soda compared to the smaller amount shows a higher rate of reaction with our vinegar. It only shows that the higher the concentration is, there will be a high rate of reaction. Concentration and pressure. Concentration and pressure are normally considered as factors because both of them refer to how many particles there are per unit volume. When concentration and pressure increases, there will be more particles present per unit of volume, which makes collisions more frequent. As a result, there will be a higher rate of successful reaction.
In this experiment, I will show you how surface area affects the rate of chemical reaction. So we need 2 glasses. Then we also need water. So we have here 1 tablet of vitamin C and another one, so a powdered vitamin C. Okay, first, so let's put the water into the glass. Same amount of water. And then we're going to put powdered vitamin C, the vitamin C tablet, at the same time. Observe what will happen. So which one do you think reacts first with water? Powdered vitamin C or the vitamin C tablet?
The activity shows that powdered vitamin C shows higher concentration rate with water compared to the vitamin C tablet. Surface area. For a given mass of a solid, large lumps have smaller surface area to volume ratios than smaller lumps or powders. If a large lump is divided or ground into a powder, the area of exposed surface increases. The higher the surface area, the higher the reaction rate.
Experiment of the effect of catalysts on the rate of chemical reactions. To increase the rate of decomposition of hydrogen peroxide, carry out the following experiment. Measure 25 milliliter of hydrogen peroxide by using a graduated cylinder. Place the compound into a clean conical flask. Add the same volume of hydrogen peroxide into another conical flask. Add the black powder of manganese dioxide gradually to the first flask only. Compare between the reaction in the first flask and the reaction in the second one, related to the rate of reaction. Oxygen gas evolves with an effervescence in the first flask, showing that the rate of reaction in it is faster than the rate of reaction in the second one, due to the effect of manganese dioxide as a catalyst.
Catalysts. Catalysts are substances that speed up a reaction. Catalyst decreases the activation energy, and it provides alternative pathways, and this means that there will be a higher proportion of successful collisions. One of the most common sources of catalysts is the transition metals like cobalt and nickel. Okay, students, so please answer learning task 2. So write true on the space provided. If the statement is correct, correct the underlined word if the statement is false. Number 1. Catalysts speed up the chemical reactions but are not changed by them. Number 2. Heat, light, or change in odor can indicate a physical change. Number 3. Activation energy is the minimum energy required for reactions to start. Number 4. Low temperature speeds up reaction rates. And number 5. A low concentration of chemical slows reaction rate. So please write your answer on your notebook. Okay, students. So please accomplish learning task 3. Number 1. Using any form of media, prepare a visual presentation of a chemical reaction involved in letter A. Food processing and preservation. Letter B. Fire control. Letter C. Corrosion control. And letter D. Photochemical smog.
E. Haber process. F. Catalytic converter. G. Car airbag. H. Formation of ozone layer in the stratosphere. I. Formation of acid rain. And number 2. Research on how the chemical reaction of the following poses useful or harmful effects to life and the environment.
Okay, students, so you will be graded according to the criteria based on our rubrics. Learning Task 4. Explain how the factors affect rates of chemical reactions. For our assessment, so choose the letter of the correct answer. So write the answer on your notebook. Number 1. It explains how collision between reactant molecules may or may not result in a successful chemical reaction. Letter A, collision theory. Letter B, tension theory. Letter C, evolution theory. And letter D, plate tectonic theory. Number 2. The following are the factors affecting reaction rate except letter A, temperature, letter B, catalyst, letter C, surface area, and letter D, stress. Number 3. The higher the temperature, the blank the reaction rate. Letter A, higher. Letter B, lower. Letter C, both. And letter D, none of the above. Number 4. These are substances that speed up a reaction. Letter A, temperature. Letter B, catalyst. Letter C, surface area. And letter D, concentration or pressure. Number 5. Catalyst blank the activation energy and it provides an alternative pathway. Letter A, increases. Letter B, decreases. Letter C, both. And letter D, none of the above. So here are the answers for our assessment. Now check your own output, but then be honest in checking. Okay, number 1. Letter A, collision theory. Number 2. Letter D, stress. Number 3. Letter A, higher. Number 4. Letter B, catalyst. And number 5. D, decreases. So what's your score? Can you share it to us? So I hope that you learned something from our discussion. In your notebook, so write your personal insights about the lesson using the prompts below. I understand that, I realize that, and I need to learn more about.
I hope that you learn new concepts and ideas from the discussions, experiments, and activities about chemical reaction. So again, this is Sir Jeffrey and Isla, leaving you with a quote from Debashis Rida. Education is a chemical reaction between the knowledge and the mind. The byproducts are